Good afternoon. These are the notes for absolute value functions. So it's going to be lesson 13.2. So the first thing we need to know, it says explain your knowledge about absolute value using words. So absolute value is a number's distance from zero. Alright, so it is literally how far away, which is why the absolute value of, like, let's say -2 is 2. -2 is 2 numbers away from 0. So today with horizontal, or with any transformations, with absolute value, we're dealing with the equation f of x equals a times the absolute value of x minus h plus k. If you remember back from when we did linear transformations, it looked a lot like this, but we didn't have the absolute value bars. We had parentheses. So the first thing says try graphing the function f of x equals the absolute value of x. Label the coordinates of the vertex. So we're going to graph this first one. So if I put a -2 in for x, I would get 2. If I put a -1 in, I get 1. 0 gives me 0, 1 is 1, and 2 is 2. So we have -2, 2, -1, 1, 0, 0, 1, 1, and 2, 2. And I'm going to go ahead and graph it, and then I'm going to label it. When you're doing these, you're going to want to have a nice pen, like sharp pens or very sharp pencils. And we need colors today because we're going to graph many graphs on the same coordinate plane. So I'm going to label this f of x equals the absolute value of x. Okay. Part C says graph in a different color f of x equals the absolute value of x minus 3 on the same graph above. Then describe the difference between this graph and the graph of f of x equals the absolute value of x. So we have a table over here that we're going to fill out. So if I plug a 1 in there, the answer is 2. If I put a 2 in, the answer is 1. 3 gives me a 0, 4 a 1, and 5 a 2. Okay, so I'm going to go back to my coordinate plane, and I'm going to graph those 5 coordinates. So it was 1, 2, 2, 1, 0, or 3, 0, excuse me, 4, 1, and 5, 2. The slope is 1, so I'm going to go ahead and put some extra little guiding points on there. And then this is going to go Okay, and the equation of this was f of x equals the absolute value of x minus 3. Okay, and if you can think back to when we were doing the linear transformations and we were using the h part, the formula is x minus h. So when I put a positive number in there, I have subtraction. So the difference between this graph and the first one is that it translated right 3 units. Okay, and it went right because there's actually a positive 3 in there. Okay, my next one, part D, says graph in a different color. So I'm going to choose orange. F of x equals x plus 2. So again, we've provided you with a table. Excuse me. So if I put negative 4 in for x, I would get 2. Negative 3 gives me 1. Negative 2 is 0. Negative 1 is 1. And 0 is 2. So again, back to the coordinate plane. And I'm going to graph those. So negative 4, 2. Negative 3, 1. Negative 2, 0. Negative 1, 1. And 0, 2. And again, I'm going to give myself extra points. Okay, and this is f of x equals the absolute value of x plus 2. Okay, so this time the difference between this and the original graph, not graphed, is that it translated left 2 units. Okay, and it went to the left because to get a positive here, that has to be a negative 2. So part E says, what is the effect of h on the equation f of x equals the absolute value of x minus h? Okay, so my first, if I have x minus h, translates the graph to the right h units, and when it looks like the absolute value of x plus h, it translates the graph left h units. Oops. Okay. Moving on. Okay, these are going to be vertical transformations. Okay, and the parent function is already graphed for us, so we don't have to do that. So part A says graph in a different color. F of x equals the absolute value of x plus h, or plus 3. So it's moved to the outside of the absolute value bars. So again, and we're always going to provide you with the tables. If you put a negative 2, you get 5. Negative 1 is going to be 4. 0, 3. 1 is 4, and 2 is 5. So we're going to go back up to the coordinate plane and we're going to graph. So you have negative 2, 5, negative 1, 4, 0, 3, 1, 4, and 2, 5. And this is f of x equals the absolute value of x plus 3. So the difference is translated the graph up 3 units. again, switching colors. So in a different color, graph f of x equals the absolute value of x minus 2. So if I plug a -2, I'm going to get 0. -1 is -1. 0 is -2. 1 is -1. And 2 is 0. And back to the graph. So we have -2, 0. -1, -1. 0, -2. 1, -1. And 2, 0. And you don't have to make your graphs extend to the end. That is just my OCD habit. Okay, and this is f of x equals the absolute value of x minus 2. Okay, and the difference from the original is it went down 2 units. So translated down 2 units. Okay, so the final question says, what is the effect of k on the equation f of x equals the absolute value of x plus k? So that effect would be that it translates the graph up or down k units. All right, moving on. Now we're into vertical stretch. And again, they gave us the parent function. So we, on part A, says in a different color, graph f of x equals 2 times the absolute value of x. So if I put -2 in, I get 4. -1 is 2. 0 is 0. 1 is 2. And 2 is 4. Okay, so -2, 4. -1, 2. 0, 0, 1, 2, and 2, 4. And as you can see, this is going to actually change the slope. This is f of x equals 2 times the absolute value of x. Okay, and when it gets skinnier on a graph, we call that a vertical stretch. So this, the change, excuse me, is a vertical stretch by a factor of 2. My next one says graph f of x equals 1/2 times the absolute value of x. So if I put -4 in, I get 2. 2 gives me 1. 0 is 0. 2 is 1. And 4 is 2. So go back to our coordinate plane. And -4, 2, -2, 1, 0, 0, 2, 1, 4, 2. And as you can see, this one didn't get steeper, it got wider. Right, when that happens, we call that a vertical shrink. So this one is f of x equals 1/2 times the absolute value of x. So, this is a vertical shrink. By a factor of 1/2. Okay, the next part, C, says to graph f of x equals 3/2 times the absolute value of x. So -4 will give you 6. 2 is going to result in a 3. 0, 0. 2 is 3, and 4 is 6. I'll go back to our coordinate plane. So I have -4, 6, -2, 3, 0, 0, 2, 3, 4, 6. Okay, and this one is kind of falling between my real steep one and my original. And it didn't get wider because it's a fraction. 3/2 is an improper fraction, so it's greater than 1. So it's going to make a stretch. So this was a vertical stretch. By a factor of 3/2. Alright, so the last question on the vertical stretch is, what's the effect of A on the equation f of x equals A times the absolute value of x? So when A is greater than 1, it's a vertical stretch. And when A is between 0 and 1, it's a vertical shrink. All right, we're almost done. We're getting there. We have one more. And that's what happens when our A value is negative. So they've already given us the graph. F of x equals the absolute value of x. So it says, again, in a different color, graph f of negative absolute value of x. So if I use the table, if I put in -2, I get -2. -1 is -1. 0, 0. 1, -1, and 2, -2. And this is because the negative sign is on the outside of the absolute value bars. Okay, so what that means is the opposite of the absolute value. So if I go to my coordinate plane and I graph, I have -2, -2, -1, -1, 0, 0, 1, 1, and 2, 2. So the negative A value reflects over the x-axis. Okay. I am going to now go over a couple of your homework problems with you. Alright, so I've written the first couple down. So when you graph, if you don't know what the vertex is, it's going to be really hard for you to make a table. Or to make a table that makes sense, that has the vertex in the center. So my suggestion to you is to figure out each of the A, H, and K, because we know what those do to a graph. So on this first, on g of x equals the absolute value of x plus 3 minus 1, our A value would be 1, because we don't see anything there. Our H value is going to be negative 3, because this became plus 3. And the original formula is subtract 3. It's x minus h. And then my k is negative 1. Remember, h is horizontal moves and k is vertical moves. So we're going to use this in reference to the original. The parent function is where everything is 1 or 0. There are no extras with it. And that always starts at 0, 0. So if my h is negative 3, that means I'm going to move my entire graph to the left 3 spaces. And then my k is negative 1, which means I need to move down 1. So there is my vertex. And then the slope of the line is 1, so that doesn't change. So I use a slope of 1 to graph. Okay, and then without needing a table, I can graph the absolute value function. And then I want to show you, you'll notice the vertex is at negative 3, negative 1 for this one. And notice what my h and k values are. So for any absolute value function that's written in function form, you can get a vertex in the form of hk. Once you have the vertex, if you wanted to go ahead and do the table and work them out, you could do that by putting the vertex in the middle. Okay, for number 7, we need to come up with the equation. So, and it doesn't matter f of x, g of x, your book started using g of x. I'm just going to say f of x is equal to, remember, a is our slope. Well, there isn't one. The slope is 1. I find it's helpful to go ahead and write the values down before I try to write the equation. My h is, did it move left or right from 0? Well, it moved right, 5. So my h is 5. And remember, k is, did it go up or down? Well, it went up to 1. So now I know each thing that I need to plug in. When an a is 1, you just don't see it. So this is f of x equals the absolute value of x, and then it's going to be minus 5, because my 5 is positive, and then my 1 is positive, so my k is going to be plus 1. So that would be your answer for number 7. Okay. Your homework for this lesson is, and it should mostly be done in class, but it's 13.2, 475 to 476, numbers 5 through 12, and 17 to 21, and that is all of those. All right. Have a great weekend.